Good morning. My name is João and today I will be talking about study of the clogging formation in injection lines of a demulsifier commercial demulsifier in Peregrino field. So those are the topics that I'm going to talk today. And first, as an introduction, we are dealing here with chemical injection system, which is a system where we introduce a specialized chemical in the flow stream. So here we introduce the chemical using the wellhead or in the hole. And the problem here is that when we are using the chemical could be a demulsifier or a scale inhibitor, some chemical that you need to introduce in your flow stream. So the problem is when we introduce the demulsifier in downhole, there are some problems that we can find here. There are some debris found in the chemical injection valve, and when your valve, for example, your valve is blocked, you cannot introduce your chemical in the flow stream. So, for example, if you use a demulsifier, you will not have something to break the emulsions, and this could bring problems to your operation problems like damaging the plant and more your fluid will be more viscosity to flow. And so we need to know the objective of this work is to understand the cause of the clogging in injection lines using the emulsifiers. So we can have problems because we use another chemical, but in this specific case, it's linked to use the emulsifier. So for that, we have some hypotheses that we made here, and to know why are the chemical injection line is clogging up. So for first case, we have the question: is that possible that the fluid already comes with solid particles? So the manufacturer send the demulsifier to the to the oil field, and then you can have already in the production of the demulsifier, you can already have some particles, or in the transportation or in the contamination in the oil field, you can have this problem. So we need to know if already have solid particles in the fluid. Another question is the demulsifier incompatible with any other product in line? So we know that we use in the industry we have, for example, completion fluid, mega, really use it, chemical use it in the to put in the umbilical or place that we need to put some fluids. So we need to know if the demulsifier is compatible with other chemicals. Then we have the variation of physical parameters such as pressure, temperature, induce the precipitation. We know that in the injection system we have conditions. First condition the platform, then we have condition in subsea. You have, for example, 4 degrees Celsius in the seabed, and then you have different chains of temperature and pressure in the line. So this induces the precipitation. We need to know. Other hypothesis is that the moves very stable for long periods of time. We need to know for how long would the emulsifier maintain their properties, and we need to know if there is something difference between along the time. And the last hypothesis that we have here is the emulsifier compatible with the materials of the injection line? In the injection line, we have some materials, for example, what is the umbilical made for, what is the elastomer that seals some parts. So we need to know if they are compatible with the emulsifier. And for that, we have a methodology that in investigation the emulsifier, we have two samples. One sample came from the manufacturer, and the second one came from the oil field. So first, we need to characterize the emulsifier, the samples. Then we made a GC to know if the emulsifier that came from the oil field is the same from the manufacturer. And then we test the hypothesis. So first, for the characterization, we made some analysis like TDS, pH, viscosity, water content, and gas chromatography. And for the investigation, for the first case, we saw the particles already come in the fluid. We used DLS, dynamic electric lighting scattering, and optical microscope to analyze if there is particles in the fluid. And for that, the conditions was the atmosphere as received and 25 degrees Celsius. And to the chemical incompatibility, we use the same equipment, so DLES and microscope, optical microscope. And here the conditions was 1 by 1 proportion 1 volume of the atmosphere with 1 volume of monoethylene glycol. We use mag, only mag at this moment, and the conditions were at room temperature. So here we saw the compatibility between the atmosphere and the mag. And the results that we had, the sample characterization, we can see here the manufacturer sample and the field sample. We can see here what the contents, ethanol, it's the solvent. They are really close, so they are really similar, the samples. Only a little difference in the TDS, but all of the other properties was equal, similar. And about the gas chromatography, to know if the sample came from the field is representative from that one which came from the manufacturer. So we saw here we have the two samples, one in green and the other in blue. If we, in the beginning of the signals, it came from the solvent ethanol, and then we have here the chemicals that are in the formulation of the fluid. So here you can have they are really similar. So we can see by this gas chromatography that they are representative. So after that, we use for the particles in fluid compatibility, the DLS, the dynamic light scattering, and the optical microscope didn't show any particles in both samples. So we don't have particles. We didn't see particles in the microscope. And when we mix maggot and the demulsifier, there was no evidence of chemical reaction. So we let them stay for a long time, and there was no reaction but a dispersion of the demulsifier into the mag. So only one fluid dispersion in the other, but not a reaction, not formation of solid particles. For the next steps, we need to investigate the residuals, the solid residues that we took from the valves. We got 3 valves, and then we got 3 solid residuals. So we can see here in the next steps we will investigate what is the composition of those debris. So for this we are going to use some of those tests. And by conclusion, we can see that the manufacturer demulsifier sample shows similar of the field sample. It was not observed any particles in both of the emulsifiers. Chemical compatibility tests did not present any evidence of chemical reaction between bag and the emulsifier, and then the results indicated that other hypotheses of clogging in chemical injection lines must be investigated. I would like to thank for all of the responses here, and thank you.